Okay, so for notes 3, it's Introduction to Significance Tests. And we're starting off with Theo as our volunteer. So we're going to write his name down here. And we're going to see how well you can play trash ball. Okay, you're going to get 10 opportunities to try to make it in the forgotten work bin over there with your awesome trash ball here. Okay, so out of the 10 shots, how many do you believe that you can make?
2.
Only 2?
I guess 4.
Okay, only 2. That's what you're going to go with? Okay, so Theo thinks he can make 2 out of 10. As a class, do you think he'll make more or less?
More.
That is so mean. Less? So which one? Less or more? Raise your hand for more.
More.
1, 2, 3, 4, 5, 6. Raise your hand for less. Okay, so more. So we're going to say he's going to make more than 2 shots. So go ahead. In group 1 and group 2, go ahead and keep count for me. That's your 2?
So maybe you were right.
You guys are supposed to be keeping track. How many? It was out of 10. It was out of 10.
What is that? So you made 7 either way.
Okay, so so he made how many?
7.
7 and missed 3. Okay. So, thank you for volunteering. So what we're going to do now is we're going to take your guys' claims. So claim 1 was Theo's claim. He claimed he could make at least 2 out of 10. So we're going to write P is equal to 0.2. Okay, for 2 out of 10 shots. You guys as a class believed he could get more than 2. So your guys' claim is P is greater than 0.2. These claims are called hypotheses, and the test to determine which one we will go with is called a significance test. Okay. So the first claim that Theo made, that P is equal to 0.2, this claim is called the null hypothesis, and we write that as H naught. So like H sub 0, we call that H naught. This can be a claim made by someone or something or a statement of no difference. Okay. Claim 2 is what you guys claimed as a class, and that is P is greater than 0.2. This claim is called the alternative hypothesis, which we shorthand as HA. So when he actually did the little experiment above, we found that his sample proportion, or in other words, P hat, was equal to 0.7. He made 7 out of 10 shots. Okay. So remember, our original claim was that he was only going to make 2, and then our claim as a group was that he was going to make more than 2. So was it exactly the claimed proportion? Yes or no? No. Could it have been the exact claimed proportion? Yes, it's a possibility. So what we're going to write here is that it wasn't equal, because instead of making 2 shots, he made 7 out of 10. So it wasn't equal, which we don't expect it to be. Because think of this as one single simulation. Okay, one single simulation. Okay. Maybe if we were to ask him to do it again, he would make 10 out of 10. Okay, or a third time, let's say 3 out of 10. Every single time would give us a different p-hat value. Okay, so we wouldn't ever expect it to be exactly the p-value claimed every single time. Okay. It says, can they have gotten this sample proportion and their claim still be correct? Well, the answer is possibly. Because again, it depends on each round that they complete, each simulation that they complete. Okay. And then the last question, yes?
The claim is, this is a guess, right?
This is, sorry, say that one more time.
What Theo said was a guess.
Was a guess, yes. It's a guess.
So it being correct would be 1 out of 10 possibility.
It being correct would be he made exactly 2, which he made more than 2, so technically it wasn't correct.
Oh, okay.
Yeah. So we're just going off of his claim, not the class's claim just yet. So it says, how can we decide if the difference is chance variation or if their original claim is incorrect? Okay. So what this is talking about is when we talked about the question before and we said possibly we could have gotten the same proportion and their claim still be correct. And that is talking about chance variation. So chance variation stands for, like, if you were to do a simulation again, would you get the same results because of skill or because of coincidence, right? And chance variation is that coincidence part. And so we're trying to differ between if it's just coincidence or if it's actually going to be data that's helping our claim. Okay, so the idea behind this is that we would need several trials to make a conclusion. Okay, and that conclusion after several trials would be, well, okay, is the number that we're getting simply coincidence, or is the number we're getting actually the true claim value?
Could it be the original claim if it was a guess? Or not the original claim, not a coincidence?
Could it, if it was a, well, that we don't know because we would have to do it multiple times. So like, let's say we had Theo up there all class period doing trash ball. Okay, he's gonna do it like, I don't know, 20 something times. If every single time he is getting close to the same amount, then we wouldn't say it's coincidence. Okay, we would say it's based off of his skill level. Okay, coincidence would be, okay, we say Theo does the simulation, gets a number, and then someone else in the class does the same simulation and gets the same number, and let's say their skill level is different, then we can say, okay, maybe it's coincidence. But we get more into depth into that in the next stats class, so if you take stats in college. Okay. So now we're going to talk about 2 different hypothesis tests, and we have a one-sided test and a two-sided test. So in a one-sided hypothesis test, it says in significance testing, we set up 2 hypotheses. The null hypothesis is the original claim, and it is always the population proportion equal to a value. So remember, population proportion is P, and our value is going to be P naught. So our value or our P naught is just a number. Okay, and that number you're going to find in the problem. Okay. The alternative hypothesis is the claim we're trying to find evidence for. Okay, so we could see that in 2 different ways. We could see that the null hypothesis is where P is equal to P naught. Okay. And notice in both of these examples, the null hypothesis never changes. Okay, it's always going to be P is equal to P naught. The only thing that's going to change is our alternative hypothesis. So since this is a one-sided test, we can have an alternative hypothesis where P is greater than P naught, or what would be the other one? Less than P naught. Okay, that's why it's called a one-sided test, because we're only looking at one side of the normal curve. So it says in a one-sided hypothesis test, the inequalities are either greater than or less than the value in the null hypothesis, which we denote as P naught, and that's the claimed proportion. Okay, so again, P naught is just a number. So in our original simulation, the very beginning, that P naught value was 0.2. Okay, because he guessed he could get 2 out of 10 baskets. That was our P naught value.
Does it matter if he gets it right or not?
It depends on the alternative hypothesis. So like as a class, you guys guessed that he would make more, right? So then what we just did is that we provided enough evidence to assume that the alternative hypothesis is true. So we're not ever talking about the null hypothesis. So it's not whether he gets it in or not, it's what our guesses were. So like if we would have said, well, less, he's going to get less than 2.
Yeah, it would be less than 2.
It would be less. The hypothesis, the null hypothesis is always equal to a value. Okay, your null hypothesis is never going to have an inequality with it. Okay, it's only going to have an equal sign. The alternative is above or below that same value. So notice in our example, off to the side, we have our null hypothesis equal to P naught and our alternative greater than P naught. P naught is representing the same number. So we could say P is equal to 0.2 and then P is greater than 0.2. Those numbers don't change. And then lastly, our hypotheses are based on our population parameter P. But do we always know P? No, so sometimes we have to use our estimate, which we call P hat. Okay, so the other type of hypotheses test is a two-sided test. So instead of just using one side, we're going to use 2. So it says in a two-sided test, we are looking for evidence against the claim, but we are unsure about the direction of difference. So what that means is instead of using a less than or greater than symbol, we're going to use a not equal to symbol. Okay. And so in order to prove that something is not equal to, you have to prove that both sides are not equal to each other. So we're using both sides in a hypothesis test when it's two-sided. Hypotheses are developed before a study is conducted. So after we gather P hat and we know which direction the difference is, we cannot go back and change our alternative hypothesis. So an example of that would be thinking back to middle school math, or not middle school math, middle school science. When you guys first learned about hypotheses, most likely you learned about an if-then statement. If we do this, then this will happen, okay? And then once you would write your hypotheses, then you would conduct a little experiment, and at the end of the experiment, you would see if your hypothesis was true or false. So after you found that it was true or false, did you go back to your original hypothesis and change it? No. What did you do instead?
You wrote down the error you made
Good. You wrote a conclusion. So you would say, in conclusion, right, even though my hypothesis was wrong and this was my findings, this is what I discovered, da 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 da. Okay, we're going to do the same thing for significance tests. So a significance test asks the question, how likely is it to get a result like this by chance when the null hypothesis is true? So we're always assuming the null hypothesis is true. So P is equal to P naught. Okay, we are then trying to prove or disprove the alternative hypothesis to see if this is actually going to happen by true statistical data or it's just a coincidence. So it says in our opening activity, if a student said they were 80% basketball shooter, it is possible for them to shoot, or is it possible for them to shoot a 50% in a single game? Yes or no? Yes. So what are they saying when they say they're an 80% basketball shooter?
If they were to make 10 shots, or if they were to make 10 shots, they'd make 8 of those.
Repetitively, right? Like on average, if they were to play basketball hundreds of thousands of times, on average, they make 8 out of 10. Okay, that doesn't mean every game they make 8 out of 10. Some games they could, in this example, make only 5 out of 10. But it would average together to that 80%. So this is a conditional probability question. Okay, what's the probability of this happening given that this has already happened? So we're going back to Unit 4 when we talked about probability. So we would write the probability that the person shoots 50% given they are 80% shooter. Okay, so the probability that they're going to shoot 50% in a single game, given that typically they are an 80% basketball shooter. Okay. If we find the conditional probability and it is small, this is good evidence against the null hypothesis. Okay. The probability of the event occurring given an original claim is called the p-value. Okay, so now we have p-value, p-hat, p-naught. They're all different things. Okay, and we're going to explain a little bit more what it means to be the p-value. Any questions so far?
Can you give me a quick, TLDR, one-sided versus two-sided? Because what I took from that was the two-sided one is you prove that both sides don't equal each other.
Mm-hmm.
The one-sided one.
So it's like how in the beginning we said, okay, we believe he was going to make more. Okay? Well, instead of saying we believe he's going to make more basketballs, we would say, well, we think he's going to make a different amount than he's guessing. So that different amount could be less than or greater than.
And that's the null that is the one-sided?
That is two-sided. So two-sided is when we say whatever his claim is, we're just going to say different.
Oh, what's one-sided?
One-sided is whatever his claim is, we're going to either claim more or less.
Okay.
So if we're claiming different, that means it could be more or less. We don't care as long as it's different. So like, for example, if we were claiming not equal to or different, since he scored, since he claims 0.2, 2 out of 10, that means we would be correct if he scored a 0.1, that's different, or a 0.3. No matter that it's lower and higher.
So it doesn't, there's no number.
There's no inequality. Like, it doesn't matter which side.
It's just
Yes,
different.
different.
And one-sided, it's just one side.
Whatever side they say. Yep, either, yep. Mm-hmm.
And then two-sided, both sides. Okay. then
Yes, yes. And we'll see a visual in this next part. Okay, so now let's talk about p-value. Okay, so the probability computed assuming H naught is true, that the statistic p hat would take a value as extreme or more extreme than the one actually observed in the direction specified by the alternative hypothesis. Okay. We compute this probability by using our sample statistic p hat and the value in our null hypothesis p naught. We will be calculating z-scores to determine the difference between what we observed, which is our statistic, and what we claim, which is our parameter. We will then calculate the probability we would get this value more extreme or extreme in the direction of the alternative and make a decision. So really what this whole thing is saying is that the p-value is the area or range of values where our p hat value falls within. Okay, and depending on if it is a one-sided or two-sided test is going to determine where our areas are. And we are going to draw a diagram once we go through the rest of this. Okay, so the two decisions that you can make is the first one that says if the probability is large, we could get p hat and h naught could be true. The null hypothesis would be true if the probability is large enough. If the probability is low enough, we would say that getting p hat, if the null is true, is so unlikely that we suspect the null claim is incorrect. Okay, so that means we would get the p hat, okay, if h naught is true, which is unlikely that h naught is correct, is incorrect. Don't worry, I'm going to give you something super easy to remember this, because this looks like crazy, right? Get p hat if the null hypothesis is true, which is unlikely that null hypothesis is incorrect. Okay, you guys ready for the thing to help you remember? Okay, so you would write, if the p-value is low, we reject that hoe.
Yes.
Okay.
So much.
Well, I'm just saying, like, it's going to help you remember. And I spelled reject wrong. Reject. Okay, so again, if the p-value is low, we reject that hoe. Which means if the p-value is small, we reject the null hypothesis. Okay, I'm telling you, you're always going to remember that. You're always going to remember that.
Yes.
Say hoe, so translate.
Because I know you guys are going to go, oh, ha, 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 that I'm, you know.
No.
So you should have to say that. Rush it.
Yes, okay. I have to be committed to it. Okay, committed to it. Last year I tried to make them not say that because I did not want you guys going around saying that. So I made them say reject HO. But then they end up saying reject that hoe anyway.
Yeah, I was saying.
So that,
I thought you were just saying.
no, it's part of the lesson. Please don't go home and say, oh my gosh, my teacher, da, da. No, it's part of the lesson, guys. It's the null hypothesis. It is the null hypothesis, again, null hypothesis, HO. Okay. Okay, everyone awake now?
Thank you.
Okay. Don't worry, I'm going to give you lots of cool memes on the board now. Every time you come to class that are going to be all different ways to remember these significance tests.
Thank you.
And you're just going to be thinking of them during the AP exam. Okay, so now we're on significance level. So we did significance tests. Now we're doing significance level. So it says, how low is a low enough probability? This is determined by our significance level. The significance level is represented by the symbol alpha. Okay. And researchers set it before the test. Okay, so just like you make your initial hypothesis before the test, you're going to set what your initial alpha value is. Choosing it is based on a few factors that we'll discuss later. If our p-value is smaller than alpha, so that means p-value is less than alpha, we say that the result of the study is statistically significant. Okay, which means that the probability of this event occurring by chance, if the null hypothesis is true, is so low that we say the difference is not due to sampling variability. So in other words, if the p-value is less than alpha, it's statistically significant, which means our data did not happen by chance. It was not coincidence. Okay, it was not coincidence. Okay. In this case, we reject what? What do we reject? The null hypothesis, right? And conclude that there is convincing evidence in favor of the alternative hypothesis. So what we just wrote here is a sentence stem. So we would say we reject HO and conclude there is convincing evidence in favor of the alternative hypothesis. So the only thing you would have to change up when you actually write this is what is your null hypothesis and what is your alternative hypothesis. Okay, because not only is it just going to be numbers, it's not only just going to say P is equal to this or P is greater than this, you're going to have to define P. Well, what is P representing in the problem? Okay, and you'll see more of those examples on the homework. And if we have enough time at the end, I'll show you that on the very first problem. Okay, any questions so far? Okay, so now the next part is going to be the opposite. So if our p-value is larger than alpha, so we write p-value greater than alpha, we say that the result of the study is not statistically significant, which means that we can contribute this data to possibly happening by coincidence. Okay, and that was because our p-value, or our area where our p-hat estimate is, was greater than our significance level alpha. And you'll see more of that when we look at an actual problem. Okay, and so we're going to write our next sentence stem. So in this case, we say we fail to reject. The null hypothesis. Notice we do not say we accept the null hypothesis, even though this one's opposite. We never say we accept the null hypothesis. We always say we fail to reject, okay? Because when you say you accept something, then you are saying that this, without a doubt, can never, ever happen by coincidence. And we're not saying that. We're saying it's less likely, that it's more likely that it would happen by coincidence than not. And conclude that there is not convincing evidence in favor of the alternative hypothesis. So again, this is all our sentence stem. The only thing that gets changed is whatever our null and alternative hypotheses are. And then again, on that next line, highlight this, something with this. We never, ever, ever, ever say that we accept the null hypothesis, ever. If you were to write that by accident, the grader, which in this case is me, right, would refuse to grade the rest of it. It would just be a 0. Okay. So we're never saying accept. Instead of accept, we say Failed to reject. Failed to reject. And plus, you sound more like science-y when you say that too. Failed to reject.
So eloquent.
No, instead of
Okay. So, when we talk about significant levels or our alphas, we typically look at a 1%, 5%, or 10%. And how we would write alpha is just converting those to decimals. So what's 1% as a decimal? 0.01. What's 5% as a decimal? Mayar, because you're in the wrong seat. You are. What's 5% as a decimal? 0.05, that's correct. What about 10% as a decimal? 0.1. Now, can you please go back to your seat? Okay. Remember, you're in the favorite seat right there, right in front of the board so you can pay attention. Okay. Now, we are going to draw our diagram so you'll be able to get the visual of what it means by one-sided and two-sided. Okay, so for each of these, I want you to draw the normal curve. As pretty as you can make it. My first one isn't, but it's okay. It's a little skewed to the... No, skewed to the left, right? It's okay, I'm going to fix it right now. So it's a little bit more, what's the word? Symmetrical. Using those stats words. Okay. So for each of these normal curves, we're assuming that the mean within each of them is P naught. Okay, P naught is that number that you originally claimed. Okay. Then, depending on what side the hypothesis is on, so we're looking at one-sided first, is where your P hat value is going to go. So on the first one, where is P hat going to go? Left or right? Left. And why is it left? Because it's less than. Where's your P hat going to go on the second one? Right, because it's greater than. And then for the two-sided, where's your P hat going to go? Both sides. Okay. Now we're going to establish our P values. And remember, our P values are the area under the curve either before or after our P hat value. So bringing a little calculus into this. Okay. Okay, so all of those scribbles that I didn't read are called our P values. Okay, it's the area before or after our predicted values. That's our second claim. Okay, depending on what our second claim is the area before or after our P hat values, okay, which we call the P values. Okay, what do you notice about the two-sided one? How many areas does it have? 2. So what do you think we're going to do with both those areas? Add them. Both of these areas are going to add together. Okay, one person said in my last class, well, if we add them together, isn't it 0? Because technically one's on the left side, one's on the right side, so one's positive, one's negative. But I'll ask you this, can you have a negative area? No, you cannot calculate a negative area. I cannot say in my backyard, I want you to create a negative 40 square foot block of concrete. Okay, they're going to look at me like, what are you talking about? Yes. Percentages? Yes. But technically we write as decimal. So you'll never see it as percentages. Okay, last part here is when we're conducting a significance test, we're still using our 4 C's. And what are our 4 C's? communicate conditions calculate. We're going to pause at calculate because I have more things to write. So on the calculate portion, you need to do two things. You need to identify your inference. So that's either you identifying it by name or by formula. Okay? And remember, what's the inference we've been doing this whole unit? One sample, you're close. Z test for proportions. Okay, remember you need to include that is a Z test for proportions. Okay, or a Z interval for proportions. They'll mean the same thing. Okay, and then in this case for this test statistic Z, if you were to write it in the formula, it would be Z is equal to P hat minus P naught divided by the square root of P naught times 1 minus P naught all over N. So again, P naught is your claimed value. Okay. P hat is the value you get after you run a simulation or experiment. Okay. P value is what? The area under the normal curve, either before or after the P hat value, and then P is the population parameter. Okay, remember we have P, P hat, P naught, P value. Okay. P value. Okay. So, drawing our normal curves again, we're going to show you how the Z statistic plays a role on this. So for the Z statistic, we always use the standard normal curve, which means the mean in this case is no longer P naught, it's standard normal. Mean is mu and mu is 0, right? Standard normal. Remember, standard normal is 0, 1 for 0 for mu, 1 for sigma. Okay, and then again, based off of which side our alternative hypothesis is which side our Z goes. And notice in this time we do say negative Z and positive Z. Because since we're using 0 as our mean, if we go less than 0, we're a negative number, correct? Okay. But our p-value is still being represented by those areas. So this is less than, so it's to the left. This is not equal to, so it's on both sides. And then this is greater than, so it's on one side. And again, those are all p-values. Where that middle one, where it's a two-sided test, we have to make sure we do what with both of those areas? Add them together. And then our very last C was conclude or conclusion. And what this does is it gives you a sentence stem on how you would answer that conclusion. And everywhere you see those, I don't know what they're called, these things. Not brackets, I don't think. Something like that. Whatever those are saying where you insert your information. Okay? So it says because of our p-value of blank is you choose bigger or smaller, then our significance level of blank, we either reject or fail to reject H naught, and then we either do or don't have convincing evidence that the population proportion, blah, 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 context of the problem.